All right, welcome. Today we are covering proving that two triangles are similar using the angle-angle similarity theorem. So this theorem tells us that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Okay, so the reason why we only need two pairs is because if you have two pairs that are congruent, then the third pair also has to be congruent, right? Because the angles of a triangle add up to 180. And so maybe we'll come up with an example of that right up here, okay? So it says, determine whether the triangles are similar, and if so, write a similarity statement and explain your reasoning. So your reasoning, if you think these two triangles are similar, using angle-angle similarity, then I'm going to ask you to set up two pairs of congruent angles, those that are the ones that match, okay? We could write three. That's a little overkill, and I'll probably do all three just to give you the options. Again, we just need to come up with two of the three pairs. So first off, let's do a quick reminder. What is this little red box? What do these little red boxes mean in a triangle or in geometry? Okay, so that just means that it's a 90 degree, it's a right angle. Okay, so 90 degrees. So that tells us that angle D and angle G, so angle D is congruent to angle G. Okay, so we've got one pair of corresponding angles that are congruent. We just need to come up with one more pair. So looking at the angles that are given, we have a 36 degrees and we have a 64 degrees. So obviously those are not the same, but that doesn't mean that those are the angles that correspond. Meaning those might not be the ones that are the same amount, just like, rotated or whatever, okay? So if this ever happens, I'd encourage you to go and find the third angle for both of these triangles. So how we can find that is we know that angles add up. So I'm going to point it to a different spot. I'm going to go from here. We know that a triangle adds up to 180. So if we get rid of the things that we know, that should give us the rest. Okay? So 180 minus 64 minus 90, that should give us the remainder. So that would be, 26 degrees. So 26 degrees. Okay, so now we can see that angle C, corresponds to angle K. So we could write that over here. So angle C is congruent to angle K. And for the same reason, we could come up with the last pair. But again, we only need to write down two, because if two of those are the same, two pairs are congruent, then we know the third also has to be congruent, okay? But I'll just do it for the heck of it. So here we could do the same thing. We could do 180. Actually, I'm going to use a different color. Maybe we'll do purple, okay? So 180 minus 90 minus 26, and that will end up giving us 64. So we know that angle E is congruent to angle H. But again, we only need to write down two only needed. I did not say that very well. Okay, so now that we have two pairs that are congruent, then we're going to say yes, it is similar, and we'll have to fill in the similarity statement. And it's important that you put the letters in the right order. We can't just randomly put, G, H, K. Okay, maybe that would match, but we'll find out for sure. So we know that C goes with K. Again, those are the angles that match. For D, we know that matches with G, because those are the angles that match. And then E would go with H. So we have to do it so that it matches, so that the angles match in the order that correspond. All right, so and we'd say by angle similarity theorem. All right, let's try another one. So if we look at this, there's no angles given at all, like no numbers at least, no values, okay? But we can use some of these properties that we've learned in the past to show that these angles are actually the same. So the first rule that or property we can use is called the reflexive property. So any angle shared by two triangles are congruent. Oh, I think I wrote that wrong. Okay, so here we have a small triangle. If you kind of see this small triangle here, and then we have a big triangle, and they both use the exact same angle. Okay, so those two angles are congruent. If you wanted to draw them separately, you could. We'd have a small triangle, we'd have a big triangle, and these would be the same. Okay, so we know if we're going to write this down, if we have to share the same like vertex, the L, like they share that same angle, we need to use more than one letter to define it. So for this one, we could do angle ULT is congruent to angle JLK. Does that kind of make sense? So ULT is the small triangle's angle, and then JLK is the bigger triangle's angle. Okay? All right. Next, we can use another property. So corresponding angles. So if we have two parallel lines, which this is what these little red rectangles represent, is showing that those two lines are parallel, then angle U and angle J, those are called corresponding angles. So if we have two parallel lines and it's cut by a transversal, so this would be our transversal, okay, then those two angles have to be the same. So we could write that down. We'll say angle U is congruent to angle J. And we could also use angle T and angle K. Those would also be congruent. So you choose two angles that correspond, that are congruent. And like I would maybe choose that because that would take less writing, right? We don't have to do as much work. But we've got to show two at least. Okay, so we'd say, yes, these are similar, and we have to match up the angle. So J goes with U, K goes with T, and then L goes with L. And we know that by angle similarity theorem. All right, next one. Again, we kind of use these special properties of angles. So if we look at this, again, we have no numbers given, but we can still know some of these angles that they have to be the same. We don't know what they are, but we know that the angles have to be the same. So first off, we want to look at alternate interior angles. So again, if we have two parallel lines, so we have that here and here, so two parallel lines, and it's cut by a transversal, so this could be like our transversal, then alternate interior angles are congruent. So alternate, meaning opposite sides of the transversal, and then interior, meaning inside those parallel lines. We know that those angles are the same. So we could say angle R is congruent to angle T. And we could actually do that over here as well. So we would know angle S and angle U. That those are also congruent. Okay? And then the last thing that we could know is vertical angles are congruent. So vertical angles, if you have two lines that cross each other, then across from those have to be congruent. So here you'd have to use three letters for this. So like SVR is congruent to angle TVU. Okay, again, we only need to pick two, so I'd maybe just pick the ones that you think are the easiest. And then the third also has to be congruent after that. Okay, so we'd say yes, and we have to fill in our similarity statement. So T goes with R, U goes with, oh, I think I messed something up. It's S and U, not S and R. S and U. Sorry. And then we've got V and V, okay, by angle-angle similarity theorem. All right, so those are pretty much those properties that we need to use, and we'll go on to the next page and we'll do just a couple more examples, okay? So looking here, we need to match some angles that are congruent. So obviously, straight away, we know that B and Z, those match. So angle B is congruent to angle Z, because that's what that's telling us, that those are congruent. And then we know that angle A and Y, angle A is congruent to angle Y. And that's all we really need to know, okay? We could infer that C and X, those angles are also congruent, but we can just stop with two. Let's say yes, they're similar, and then write down the angles that correspond. So A goes with Y, B goes with Z, and then B goes with Z, and then C has to go with X. Angle, angle, by angle, angle similarity. All right, let's look at this one. This one's a little, we had one kind of like this in the past. Again, we have two triangles that are just touching each other. We have this bigger triangle, and we have this smaller triangle. Okay, if it's helpful, we could redraw them and rotate them so they kind of match where everything is. Okay, and then we know that this is 52. And we also know that this angle over here is 90 degrees. So if the green triangle is 90, then the red triangle that's touching it, right, is 90 degrees as well. So now it's kind of like that first problem. We can easily find then those two 90 degrees, those are the same. So we could say angle CFD is congruent to angle DFE. Okay, and then to find another pair, we'd need to use the property that the angles of a triangle add to 180. So we could find this by doing 180 minus 90 minus 52, and we would end up, let's see what we'd get. Just want to double check that. So I think I end up getting 38. Okay, and if we were to come up with this one as well, if we did 180 minus 32 minus 90, that would give us 58 degrees. So matching these and matching this, we would find that they are not congruent, they're not the same. So we would just stop there and write no. There is no similarity statement, but how we know is angle-angle similarity. Okay. All right, so next off is just using some real life similar solving problems, okay? So it says a flagpole cast, so let's draw a little flagpole. So we got a flagpole. So our flagpole casts a 50-foot shadow. At the same time, a woman is standing nearby. That's 5 feet 4 inches. Okay, so here we're going to have to be a little cautious here. We have to have the same units. So we've got feet, and we have the woman that has feet and inches, and then her shadow is just inches. So we would need to either get everything to feet or get everything to inches. So I think the easiest way is just to multiply anything that's feet by 12 so that it would be in inches. So 50 times 12 would give us 600 inches. And then here would do 5 times 12 plus 4. So 5 times 12 plus 4 would be 64 inches. And then we already have this one's in inches. So let's maybe change this so we're all doing the same units. So this would be 600 inches. Her shadow was 40 inches, and her height is 64 inches. Okay, I guess maybe I'll stay consistent. There we go. Okay, and then we want to know how tall is that flagpole. So we'd say something like, again, find your x, find what corresponds. So we'll have x over 64 is equal to 600 over 40. And then we'll do one step to get x by itself. And we'll end up getting x equals 960 inches. And then it does say to write it in feet to the nearest foot. So again, we'll just need to switch that back, divide that by 12. So 960 divide 12, and we get 80, x equals 80 feet. All right, last one. So when a Ferris wheel casts a 20-meter shadow, so here's my little Ferris wheel, okay, casts a 20-meter shadow, a man at 1.8, who's 1.8 meters tall, casts a 2.4 meter shadow. How tall is the Ferris wheel? So that's our x. So again, same sort of thing. We would match, set up the proportions, multiply both sides by 1.8. Sorry, my pencil is not working super well today. Okay, use our calculator. We end up getting 15 meters. Okay, well, if you have any questions, please let me know. Hopefully that kind of made a little bit of sense. If not, please come in and we can chat. We'll see you later.